while V is volume of the water displaced.
I'm Jin-Yao, and now I'm going to present the objective of this experiment. First and foremost, the objective of this experiment is to determine the height of metal center by using the Taylor method. The theme of the whole experiment is to find the stability of buoyant object based on the principle of fluid mechanics. That means our report is going to discuss about a relationship of center of gravity, metal centric height, buoyancy, weight, and angle of tilt. Lastly, this experiment is going to describe the change of floating protein when it is loaded with a weight. Thanks you, and I'm going to pass the presentation to my group mate.
Hi, I'm Aida. I'm going to explain the theory and also the related applications used in this experiment. Firstly, the knowledge on the stability of pontoons such as a floating ship is very important. Why? This is because this knowledge is widely used in our daily life, especially for the people who design ships and ferries. So how can we know if the floating body is stable? A floating body is considered stable when it is displaced, it returns to equilibrium. If it is unstable, when it is displaced, it will move to a new equilibrium. In figure A, we could see that there has a floating body which is in equilibrium under the action of two equal and opposite forces. The two equal and opposite forces that I mean are the weight W, and the weight is acting vertically downwards to its center of gravity. We also have the buoyancy force. The buoyancy force has the equal magnitude with W, but it is acting vertically upwards at the center of buoyancy. So this center of buoyancy is located at the center of gravity of the fluid displaced by the floating body. And we need to know that when in equilibrium, the points center of gravity and center of buoyancy will lie in the same vertical line. As the floating body tilts, the center of buoyancy will move sideways, but still it remains at the center of gravity of the displaced liquid. In figure A, it is possible to obtain stable equilibrium even when the center of gravity G is located above the center of buoyancy. It is because the weight and the buoyancy force will together produce a restoring moment. The restoring moment will rotate the body back to its untilted position, to its original position. But in cases for a relatively tall, slender body like in figure B, a small rotational displacement could already cause the buoyancy force and the weight to form an overturning moment. So an overturning moment will rotate the body even further in the tilted direction. In this experiment, we will determine the stability of a pontoon with the center of gravity at different heights. If a horizontal weight is moved with a distance x from the center, the pontoon will tilt. The angle of tilt can be measured by using the plumb bob. We also could determine the equilibrium condition of a floating body experimentally using the equations and formulas below. In equation 1, we have C naught, which is overturning couple, is equal to mgx. M stands for mass of horizontal weight in kg, while G is the gravity constant, 9.81 meter per second square, and x represents the distance by which the horizontal weight is moved in meter. In equation 2, we have writing couple CR is equal to capital M, G in bracket, GM, close bracket, tan theta. So capital M is the total mass of pontoon with the vertical weight in kg, and GM is the distance between body's center of gravity to the center of matter in meter. So for equilibrium condition, C naught will be equal to CR, then GM is equal to WX over capital W tan theta. Then we could compare the results obtained from the experiment with the calculation. Calculation using area of second moment is as follows. We're going to have equation 4. Bm equal to I over V. Bm is the distance between body center of buoyancy to the center of matter, and I is the second moment of water surface area at vertical axis. Lastly, we will get equation 5, which is Gm equal to Bm minus Bg. Then Bm minus Bg is equal to Bm minus Y plus D over 2. Moving to the related applications used in this experiment. Firstly, we will need a water tank. Then we will need a pontoon, which is complete with the thread, vertical weight, horizontal weight, and also we will need a pontoon stabilizer. And lastly, we will need a ruler for measurement purposes. That's all from me. Thank you. I will pass the presentation to the next presenter.
Okay, so my name is Ahmad Zikrin. I will explain to you the methodology of this lab experiment. So for the first step, the horizontal weight was removed and the height of the vertical weight on the mast of the pontoon was fixed. For the second step, the center of gravity was determined by putting the pontoon mast on the pontoon stabilizer. Then the length of the center of gravity, which is the half distance from the base of the pontoon to the center of vertical weight, was measured. For the third step, the horizontal weight was fixed, which is 1.16567 kg, and the thread was ensured to be at 0mm position at the middle, so there will be no tilt at the thread. For the fourth step, the tank was filled with water, and the pontoon was placed in the tank which is filled with water. The fifth step, the length of the pontoon was that was submerged in the tank is measured by using a just standard ruler. For the sixth step, the horizontal weight was moved 10mm to the right, and the angle of the tilt of the thread was recorded. For the seventh step, we repeat step 6 by moving horizontal weight to the right with 10mm increment. So it starts from 0mm, and then it increases by 10mm, and then goes to 20mm, and so on. So by that, the angle of tilt was recorded. This step is repeated until the plumb bob, which is hanging by the end of the thread, touch the side of the pontoon. For the eighth step, step 6 and step 7 were repeated by moving the horizontal weight, this time to the left. So same step, 10mm increment, 10, 20, and so on, and the angle of tilt was recorded. So for the ninth step, the height of the vertical weight is adjusted to a new height, and we repeated step 1 to step 3, followed by step 5 to step 8. In the end, this test was done for two different values of vertical heights. That's all from me. Thank you.
Assalamualaikum and hello everyone. I am Azin, will present the result and the discussion part. We see the result first, which is, as you guys can see on the slide, the value of metacentric height GM for the test 1 test 2 and the test 3. In this table, we need to add table for radian because we using the XL formula, which is we put in the formula of metacentric height GM in the XL, and then it generate the answer. But the angle of tilt we need to use in the radian instead of degree because XL cannot use theta in degree. Next, for the discussion part, question number 1, which is plot the graph of metacentric height GM versus theta for each test. Determine the value of GM from the plotted graph when theta equals 0. As you guys can see on the slide, for the test 1, we plotted metacentric height GM versus theta in degree. Then we managed to get the equation from the XL tool and the y-intercept, which is 0.0499. For the test 2, as you guys can see on the slide, we get the graph using the XL tool, and then we managed to get the y-intercept, which is 0.0816. Last, for the test 3, as you guys can see on the slide, we managed to get the y-intercept, which is 0.126. Then we managed to get the graph and the equation from the XL tool. Then from the question, we need to find the value of metacentric height GM from the plotted graph when theta equals 0. From our understanding, when theta equals 0, the value of metacentric height GM is equal to y-intercept. From the graph, we managed to get the value of GM for the test 1, 0.0499 meter, test 2, 0.0816 meter, test 3, 0.1260 meter. That's all from me. Thank you. Next, I will pass to the next presenter.
So the next question is calculate the value of GM for each test using an area of second moment. Compare and discuss the obtained value with the value from the first question. So the formula of second area of moment is GM equal to LB cube over 12 times rho over W minus Y plus D over 2. And the given data for the experiment is mass horizontal weight, which is 0.28078, the mass of pontoon, which is of pontoon with vertical weight 1.6567 kg, width of pontoon 0.2 meter, and length of pontoon, which is 0.35 meter. So for the test 1, the CG is 0.18 meter and D is 0.02 meter. After calculating using the formula, the value of GM is 0.03017 meter. For the test 2, the value of CG is 0.09 meter and D is 0.02 meter. After calculating the GM, the answer is 0.1202 meter. And the last one is for test 3. The value of CG is 0.02 meter and D is 0.02 meter. The value of GM for test 3 is 0.1902. So based on the value of GM from calculation and graph, the value of GM for each test is slightly different between the graph and the calculation. This is because of the error while doing the experiment, such as the parallax error. And another information that we can get from this experiment is when CG is decreased, the value of GM will increase. And then for the next question, which is question 3, discuss the reliance of the meta center on the position of the center. Discuss the reliance of the meta center on the position of the center of gravity in terms of stability of floating body. The first one is metacentric height is the measure of stability for floating bodies. The next one is a floating body is stable if point M is above point G and the GM is positive. while it will cause unstable if point M is below point G and the value of Gm is negative. And the last one is the length of the metacentric height Gm is above G is measure of the stability. The larger it is, the more stable the floating body. And the last question for the discussion is discuss the effect of variation in angle of tilt of the position of the metacenter. So from our discussion, the first one, the answer for this question is it will change the position of metacenter at some position of metacenter, and at some maximum angle the stability of floating bodies also will change.
Thanks, and now I'm going to present the conclusion of the experiment. First of all, our objective of determining the height of metacenter is achieved. Secondly, we prove that the angle of tilting changes the metacenter and the center of gravity. Other than that, we also found out the stability of buoyant object depends on the position of buoyant force and center of gravity. The buoyant object having higher stability when its metacenter is higher than the center of gravity. When the buoyant body extended a vertical force, the body will return to its original position by the equilibrium system of buoyancy force and weight as soon as the external effect is removed. We also proved that the smaller angle of tilting, the higher the metacenter. And then, our experimental result is slightly different with the theoretical value that was obtained for the equation. This is because there are some errors such as systematic error and random error happen during the experiment.